Hello students, we have seen distance formula. So let us see what are the applications of distance formula. So first you have learned what is that distance formula. Let me know if there are 2 points, any 2 points with coordinates here x1, y1 and x2, y2, then the distance between those 2 points. If I am having point A, right, which is having x1, y1 coordinates and another point any B which is having any coordinates which is x2 y2. So what is the distance formula? You have already learned x2 minus x1 whole square plus y1 minus y2 minus y1 whole square, right? Or you can take it here, or I can use here x1 minus x2 also, x1 minus x2 whole square, because it is whole square, so it is not going to change your answer, right? So this is the distance formula. Now, what are the places? What are the application of this distance formula? Because you will see the case study question from this chapter, right? So let us see here. The first application is collinearity, to check whether the given points are collinear or not, right? So if I say here, what is the first application you will see here? You will see the first application here to check collinearity or collinear point. Now in this case, if I have to check if A, B, C are collinear points, what is the meaning of collinear points? All the 3 points should lie on a straight line. So if I'm drawing a straight line, right? And if there are 3 points A, B, C, right? They all should form, it should be part of a line. That means A, B, C are collinear. So what is this here? If you will see, I can see three lengths, right? I can have here AB, or I can have BC, or I can have AC, right? So in this part, if you will see, AB plus BC is AC. So if I can get it, because AB is a distance. So using distance formula, I'll get the length of AB, because you will have your coordinates, right? You'll have some coordinates here. So you can use here, if I take x2, y2, and here there is a third coordinates x3, y3, and the first coordinate is x1, y1. So can I find out AB length? Then I can find out here BC length, and I can find out here AC length. So as per the first condition here, if AB plus BC is equals to AC, then you can say that ABC are collinear. But I don't know the position of these 3 points, right? So because if I'm drawing, this is your first case. What can be the second case here? The point, because these are the coordinates, they will just give you the three coordinates, they will not tell you it is in which order. So can I have here A, C and AB? That means here if I am having here, this is A is in the middle, this is C, this is going to be B. Now as per this, do you know BC is the total length, right? Or I can write down here B and the other part as C, correct? So let me write down here C. Now you know that AC length, this is AC length. So what I need to check here, AC plus AB, if it is equals to BC, because now in this case, if you will see, BC is the total length, A is in between B and C. Similarly, you can have the third case also where C is in the middle, right? So you need to see that, you need to check all, if any two, these three lengths you need to find out, right? So here, if this is the point here is C, and this is here B, this is A. Now from here you can say that BC plus AC is equals to AB, then these 3 points are collinear. So what you need to do in these kind of questions, you have to find out the length of AB, BC and AC, and take the sum of any two of these length. If it is equal to the third length, that means the 3 points are going to be collinear. Now, how are you going? This is your first case where you use the distance formula, because you are using here all the length. That's why you have to use the distance formula. Now, what is the, this is your first application. What is the second application? You identify which kind, which type of triangle you are going to get it, right? Because we are talking about, again, there can be the three coordinates given, right? So to check the type of triangle, so you know that again they are going to, because it's a triangle, how many coordinates they'll give you? Always they'll give you here three coordinates. So if I'm having again x1, y1, This is the first coordinate. Then they'll give you the second vertex coordinate x2, y2, and the third coordinate, which is c, x3, y3. Right? Now, for equilateral triangle, you all know that the length of three sides should be equal. So please draw it. You'll understand here. So if I draw here a triangle, which needs to be equilateral triangle, that means all three sides must be equal, right? So here if I mark here ABC, what do I need to check? Using distance formula, I'll find out AB. So always first you draw and then you write down. So easily you will understand which distance you need to find out. This is Y2 and C is X3, Y3, right? So I will find out AB length. Now if I'm finding after that, if I'm finding BC length and then I'm finding AC length using distance formula. Now if all the three lengths are equal, then it is going to be an equilateral triangle, right? Similarly for isosceles triangle also you are going to repeat the same thing. Any two length of any two sides are equal, right? So let us see here what is the second case. This is about isosceles triangle. So draw it again. You are going to find out the length of three sides. So here any two sides, it can be AB equals to here. If I'm taking the same thing, AB can be equals to BC or AB equals to AC, or what can be the third case here? AC equals to BC, right? If this is true, but it is not equals to the third side, here it won't be equal to AC. In this case, it will not be equals to BC. In this case, it will not be equals to AB. Then it is going to be an isosceles triangle. So for the triangle, you need to use distance formula three times, right, to find out those three lengths and then do the comparison. Now, scalene triangle, you all know that none of the sides should be equal. So distance formula, find out those three lengths, right? So for scalene triangle, how are you going to do it? Same thing, but AB will not be equals to BC. So what is the case? You will get it length using distance formula and none of the sides should be equal, right? Then it is a scalene triangle. Generally, you get questions for equilateral triangle and isosceles triangle. Now, sometime you get it right triangle also. Now, how are you going to get the right? How are you going to check the given coordinates? Three coordinates are of right triangle. Same thing, you are going to find out the length of two sides. But for a right triangle, what it should be? I should be having 90 degree. Now I can't measure the angle. I'll be getting only the length. So what are you going to use it here? I don't know. It can be anything, A, B, C, anything. But if our Pythagoras theorem is true, right? If Pythagoras theorem is true, that means the find out the longest length, right? Because longest length is, if I'm taking here AC is the longest length, then here, so you have to just prove that longest length square should be equals to square of sum of other two sides, right? So I have taken AC here. Otherwise, you have to remember here longest length, right? Because when you use the distance formula, you can get the length, you can see the length. So longest side length, right here, this is the side length equals to square will be equals to the other two sides, side 1 square plus side 2 square. If this is true, that means how to check equilateral triangle? I have to prove that LHS is R equals to RHS. So I have to take AC length square and I have to prove that it is equals to the sum of square of the other two sides. Then the triangle is going to be right triangle. So you can see that in all the four cases, you need to first find out using these three coordinates. You need to use distance formula and get the length of those three sides first. And any whatever they are asking, you can check and you can find out which kind of triangle it is. So first part, what did we see? What is the application of distance formula? It is to checking whether the given points are collinear or not. Generally, you will get always three, because two or more points it's on a straight line, any point which is on a straight line, then it will be collinear point. Then to check, you have to find out which type of triangle it is, right? Then the third application it is how are we going to which type of quadrilateral it is. Now to check the quadrilateral, how many coordinates you will have always? There will be always four coordinates, right? Because quadrilateral it is made by four sides, four vertices. So number of coordinates they will give you, it will be 4, and whatever order they have given, make sure you do not change the order. So first thing, if it is A, you will take the first coordinate as A, because whatever coordinates are given, I am going to make the quadrilateral using in the same order, clockwise or anti-clockwise. So my first coordinate, if it is x1, y1, second coordinate is x2, y2, right? Third coordinate is going to be x3, y3, and the fourth coordinate if it is x4, y4. Now you need to remember all the properties of quadrilateral, because those properties of quadrilateral we use to check which kind of quadrilateral it is. Now the first type of quadrilateral you will get to see here is parallelogram. Now what is the parallelogram? You know that opposite sides are equal. What are the properties of parallelogram? So first always draw the parallelogram here, right? So you will remember, it's easy to remember the properties when you are drawing with the figure. Let me redraw this. So here, right, and then this is there, correct? So if it is a parallelogram, now you know that if ABCD is a parallelogram, what are the properties? I have to check it. Opposite sides are equal, right? And diagonals, because what happen if opposite sides are equal, it can be a rectangle as well. So what I need to check it here, to check it's a, if it is a parallelogram, then you need to check if opposite sides are equal, right? To check if it is a parallelogram, please check opposite sides are equal. Please take it in the same order, A, B, C, D, whatever four coordinates are given, or P, Q, R, S, right? Or any other vertices name, but it should be taken in the same order, right? So what I'll take it here, AB, I'll find out the length using distance formula, should be equals to DC, and AD length, which is the another opposite pair of opposite sides, should be equal to BC. But this is the first condition, because in a rectangle also opposite sides are equal. So how will you specify whether it's a parallelogram or a rectangle? So for that, I am going to find out the length of the diagonal as well. What is the length of the diagonal? In rectangle, the length of the diagonals are equal, but in parallelogram, they are not equal. So I have to prove all these things, because you need to find out first AB, BC, CD, AD, and then the diagonal length, which is AC and BD, and you have to show that AC is not equals to BD, right? AC is not equals to BD. This is for a parallelogram. So please remember, generally there will be always four coordinates, and you need to find out all these six lengths. Whenever there is a quadrilateral, you need to find out six lengths. Length of four sides and length of two diagonals. Okay. Now what is the second type of quadrilateral you will get to see? It will be a rectangle. Now for rectangle also, I'll find out here length of opposite side. So if it is a rectangle, right, I have to draw a rectangle. This is too easy to understand, okay? So, and it's easy to read also for distance formula if you're drawing the figure. We'll see whether it's a rectangle or not, right? First, I'm just marking as a quadrilateral ABCD. Now, a rectangle also, because we can't check whether there is a 90-degree angle or not. We are just talking about the length. Length-based properties are always based on side and diagonal. So, opposite sides are equal. So, you mark this is equal, and diagonals are also equal. So, what is the case you will check here? AB is equals to DC, AD is equals to BC. All these are and, okay, and diagonals are also equal. So what are the two diagonals we have it here? The diagonals are AC, right, and BD length, right? So I have to check here AB is equals to AC because it's a diagonal length. So here AC is equals to BC. Now here it is AC, diagonals are equal, here they are not equal, correct? So after that, what is the next type of quadrilateral you will get it to check? It will be rhombus and square go, they both will go together, right? Because rhombus also all the four sides are equal, and in a square also all the four sides are equal. So let us see here. For the rhombus, I have to check all sides are equal. Now rhombus again you can't check whether the diagonals are perpendicular bisector or not because we are talking about only length. So let us first draw a rhombus. Rhombus is a parallelogram with equal side, right? There's no 90-degree angle. So if I try to draw a rough figure, I have to check. I'm just drawing AB. I'm just drawing a quadrilateral, right? Now for ABCD to be a rhombus, all four sides should be equal and the diagonals are not equal because in square, what is the difference between rhombus and a square? In rhombus, diagonals are not equal, but in a square, diagonals are equal, right? So you can write down here AB, you can write here also. ABCD is a rectangle if all these three lengths are equal, right? Here also ABCD is a rhombus. For rhombus, again I'll calculate all the four sides, length of four sides using distance formula. And if I'm able to show or if I'm able to get AB is equals to BC is equals to CD is equals to AD, and okay, all these cases should be true, AC is not equals to BD, then we can say it is a rhombus, right? Now after that, what is there for square? Square, all four sides will be equal and diagonals are also equal. So you can take parallelogram and rectangle together and you can take then square also, right? Square and rhombus together, right? So here for all the sides should be equal. So what do we take here? Let us try to make a square here. This is a square property. So remember all these properties. It will be easy. Questions come based on this, right? So if this is a square, again I can't talk about angle. This is ABCD. So square also like rhombus, all four sides are equal. What is going to be the specific property? Diagonals are also going to be equal for a square, but the diagonals of a rhombus are not equal, right? So let us see here ABCD is a square. Here if, right? Square if, what is the first one here? AB is equals to BC is equals to CD is equals to AD. All four sides are equal and diagonals are also equal, right? So these are the application. You have to remember all these properties. So what is the property here? Let us do the quick recap here. First thing, to check the collinearity, you should know that you will find out those three lengths, sum of any two length if it is equal to the third length, the points, those 3 points are collinear, right? And after that, to check the triangles, you will get the three coordinates, you will check all those properties. To check which kind of quadrilateral it is, there can be four types of quadrilateral. If it's a parallelogram, opposite sides are equal, diagonals are not equal. If it's a rectangle, opposite sides are equal, diagonals are also equal. For a rhombus, then all sides are equal, diagonals are not equal. And for a square, all sides are equal and diagonals are also equals. So these are the application based questions. So we'll solve the questions in our next session. Thank you for watching this video. Please like, share and subscribe. Also keep practicing.